Today we're going to talk about the slope of a line. So we know a line, or in other words, a linear function, will always have a constant rate of change, and that's the most important thing about a linear function. Now we can model that change with the phrase that I've listed below. Every time we see x do something, we should see y always do the same thing. Now today we're going to formalize that constant rate of change, and we're going to introduce the word slope. So the slope is the constant rate of change. And we already know that the way we can describe that would be the change in y over the change in x. Now there's a few other ways that we could write this same thing. We know that y is really just a placeholder for the dependent variable. It doesn't always have to be y. So we'll call that the change in the dependent. And then we know x is just the independent variable in most cases, but it doesn't always have to be. So it's the change in the independent. And there's a few other things that are going to be really important. We know that the dependent variable, or in other words, the y variable, that's the y-axis. That goes up and down. So a lot of times we like to call this the rise, right? Rise up and down. Over the run, the x-axis runs left to right. So another thing we can refer to as the rise over run. And then there's one more formula that's going to be really helpful for us today. The change in the y value means we have two y values. We want to know how far apart they are. So we can use a formula y2 minus y1 over x2 minus x1. Now every single one of these formulas is going to help us for a different purpose, because as we can see, there's going to be four major ways that we describe the slope of a line. So we already have seen the words, right? The words up here, if we just draw a little line, the words, that's what we already have up here. Now for tables, we'll use multiple different ways of the slope, and for graphs, we'll use a different form of the slope, and then equations will be another way that we can describe the slope. Now just moving forward, so we don't always have to write the word slope, there is a letter that we're going to use to represent the slope from now on. So whenever I write the letter M is going to represent the slope, so I don't have to write it every single time. And that's the letter that we'll use in class, and that's the letter that we use in math in general for the slope of a line. So for this, we want to find the slope of this table. We're going to start with words, and then we're going to use some of the other representations. So first, we're just going to look for the pattern. So what we can see in the table is that it's going up 1, and the x values every single time. And the y values, I can see that they're decreasing by 3. So every time that the x variable changes by increasing 1, we see that the y value always went down 3. So our slope, which is the letter M, right? We know it's the change in the y over the change in the x, right? We're using this one first. So the change in y was a minus 3, and the change in x was a plus 1. So we can reduce this fraction just to the number negative 3. So the slope in this table is negative 3. Now let's look at one more way we could have also have done this. We could use this formula as well. Now what that means is we've got to pick a point. So let's use this point on the table, and let's use this point on the table. So our first point was negative 1, 7. And since it's our first point, we're going to call that x1, and that y, the y1. The second point was 2, negative 2. And again, just because it's our second point, we're going to label the x value as x2 and the y value as y2. So if we were to plug in our formula, the slope, we take our y2 value, which was negative 2, and we subtract our y1 value, which was 7. And on the bottom, we take x2, which was 2, and we subtract x1, which was negative 1. Now, negative 2 minus 7 is negative 9. And then here we get 3. If we reduce that fraction, we will get negative 3. So no matter which form or which points we choose to use for the slope, we see that the slope of this line, or the line that's outlined in the table, is negative 3. So we have another example of a table. We want to find the slope. So with this one, I think this one's slightly different. We do start to see a pattern right away, so we can use kind of the words. What we see at first is we see that x is increasing by 3. And it seems that every time x increases by 3, the y value increases by 6. But then we get a little concerned when we move a little forward here because we see that x only starts increasing by 1. But then the y value only starts increasing by 2. So let's start with the change in y over the change in x and make sure that this really is linear and we can find our slope. So for the green points, what we saw that the change in y, it was always going up 6 every time x went up 3. So our slope, the letter m, there was 2. If I did the yellow points, the slope there, we would see that the change in y, it went up 2, and every time x went up 1, so that does reduce to 2. When we use a different formula, we could again go ahead and use the points, so we could pick any 2 points in this table. So let's choose 0, 2, and 5, 8. So let's label this point 0, -2. Let's denote that as our x1 and our y1. Let's go ahead and denote the point 5, 8 as our x2 and our y2. And then if we plug it into the formula, our slope, so y2 is 8, y1 is -2, and then on the bottom we take x2, which was 5, and we subtract x1, which was 0. So then on top we're left with 10, after we change that, over 5, which is 2. So no matter how I do it, I can clearly see that the slope outlined in this table was 2. So here we're supposed to use a graph to find the slope of a line. And when we have a graph of a line, I think it's usually easiest to start by looking at the rise over the run. So the rise over the run is how far up and down did we go and how far left and right did we go. So we need 2 points to start with. So let's look at this point and let's look at this point. We need to know where we're starting. So let's pretend that we are starting right here. So the rise is how far up and down did I go from my starting point all the way over to my ending point. So if I started right here, I would have to go straight down this far to be in line with my ending point. So in other words, the rise, or how far up and down I went down 3 units. Now the run is how far left and right would I have to go. So if I was here, I'd have to go this way. And that is the run in this formula. So the run, I increased my x value from 0 all the way over to 4. So our slope, the rise was a -3, the run was a +4, and that just reduces to -3 over 4. Now given a graph, if we have points on it, it's also easy to use the point formulas. So again, I'm just going to label this my starting point as x1 and y1, my ending point as x2 and y2. And if I do it this way, I should get the same answer. So y2 minus y1 would be 0 minus 3. x2 minus x1, so we'd get -3 over 4. Given this graph, let's find the slope using the rise over the run. So the first thing we have to do is pick a starting point and an ending point. So I can see that these 2 points are on the graph. So just because I'm deciding right now, let's start at the bottom here, and let's pretend this is our end point. So if I was going to take an up and down distance from my starting point to my ending point, I'd go straight up here, and I would see that that rise, the up and down, I went from -2 all the way up to 2, so 1, 2, 3, -2 all the way up to 4. So that's an increase 1, 2, 3, 4, 5, 6. So I increased 6. So my run, how far left and right did I go? Well, I was here, so I went 1, 2. So that run was also a +2. So m, the change in the rise over the change in the run, was equal to 6 over 2, which was equal to +3. Here we have another graph, and they also do give us a table of values that represent that graph. We're supposed to find the slope. Now, the first thing we should see is that this is going to be important because we can already identify that this is a horizontal line. So let's use 2 different ways of seeing it. First, let's look at our slope as the rise over the run. So we have to pick 2 places on our graph. So I see that point right there. I'll start, and this will be my end. So I'm just going to label that as my end point, and then this was my starting point. So if I was asking myself, how far up and down did I have to go from my starting point to my ending point? I wouldn't have to go anywhere. That up and down distance was 0. I don't want to move up and down. To get from here, all I have to do is go over, right, from -5 to 5. So if I counted that, that looks like I went over 10. So 0 divided by 10. We know how to divide by 0. If there was 0 pizzas and 10 people sharing them, every person would get 0 pizzas. Now, if we look at the table up here, which is another really important thing to see, we could just pick 2 points from that table. So let's just call this our x1 and our y1. Let's call the second point our x2 and our y2. So if we were to calculate the slope using the formula, we get y2 minus y1 over x2 minus x1, which would be 0 over 5. And again, that would also simplify to 0. So the slope of a horizontal line is 0. The last thing I would point out to you is we should be able to recognize this as a horizontal line in the table as well, because all the y values are equal to 3. So this is the horizontal line, y equals 3. Now here we have another graph to find the slope of, so another very important example. We can see clearly right now that this is vertical though. And this is a vertical line for 2 reasons that we can see right now. First of all, because it's just straight up and down. And second of all, if we look at the table they gave us, we can see that all the x values are the same. So I know that the rule to be on this line is the x value needs to be 5. So this is the vertical line, x equals 5. So what is the slope of this vertical line? Well, let's do 2 things again. Let's start with our rise over the run. So we'd have to pick 2 points on our graph. So I'm going to use this one. I'll highlight them. So the starting point, let's start right here at 5, 0. So this will be our starting point. And then our ending point, let's just choose this one, which was 5, 5. So I'm labeling that as E for end. So our rise, well, how far up and down would I have to go? Well, I went from 0 up to 5, so I went up 5. Now, how far left and right would I have to go from this point to that point? Well, none. I don't want to move left and right at all. I just want to go straight up. Now here, really important to remind yourself, we cannot divide by 0. So this fraction here, 5 divided by 0, is undefined. So the slope of a vertical line is undefined. Now if we do this in our second way, if we just pick 2 points, so like 5, 5, and 5, -1, we'll label this x1 and y1, x2 and y2. So our slope formula, y2 minus y1 over x2 minus x1 would give us -6 over 0. And again, we can't divide by 0, so that would tell us that that answer is undefined. Not 0, undefined. So the slope of a vertical line is undefined. So this is a quick summary of the 4 types of slopes that we went over today and giving them actual names. So the first type of slope that we're going to see is a positive slope. A positive slope we can see rises from left to right. And we know that if we looked at a number, like our value of m would be some sort of positive number. Right below that, we have a negative slope, and a negative slope falls from left to right. So if I start up here on the left, and as I make my way towards the right of the x values, the y values are falling. So what that means, if we calculate our m like the actual number, we should see that that is a negative number when we get the value of the slope. The other 2 special cases we saw were the vertical line. So for the vertical line, we say that that had an undefined slope. So a vertical line, which I'm just going to label here. And for the vertical line, what we see is we get m as a number would be some number divided by 0. So 0 is in the denominator, and we can't divide by 0. So so that's why it's undefined. So a vertical line has an undefined slope. And then the last example that we saw was that of a horizontal line. So I'm going to label that. And when we did it as like a slope formula, m, here's where we got 0 on top and a number on the bottom. And we know that we can divide by any number we want as long as it's not 0. So this will always come out to 0. So the slope of a horizontal line is 0. The last way that we'll represent slope is just from an equation. So not actually seeing a graph, but just being given an equation. And there's a special rule here that if you're going to find the slope given an equation, it has to be in a special format called slope-intercept form, right? Y equals mx plus b. So if it's in that form, like this one is in that form, and what we mean by that form is that y is all alone. So y is all alone on its side. There should be some number in front of the x value. So there should be some number m in front of an x value, so we can see that the x value has a number in front of it. And then there's this number just at the end, plus or minus b. So what we can see here is that the slope, the number in front of the x, so our m value, our slope is 3. So that's our slope for this equation. The next one over here is also written in the same format. We can see that y is all alone. And then there is some number in front of that x value. So the number in front of the x value is our slope. M, in this case, would be -1/2. So this is a negative slope, so it should look on a graph something going downward. Now number 3 is not in that form, so we must rewrite it first. So if we're going to rewrite it, we want to get the y value alone. So let's go ahead and subtract 4 x's from each side. So we have -2y was equal to -4x, and then that was a +12. So we need y to be alone, so our last thing would divide by -2. Everything divided by -2, so finally we get y equals 2x minus 6. So the number in front of that x value, when it's all alone, is 2. So the slope of this line is equal to 2. Our last example over here, y equals 3. This is, first of all, we should recognize, since it's just y, this is a horizontal line. We automatically know that the slope of a horizontal line is 0. But another important thing to see is we could have taken that y equals and just rewrote it as 0x plus 3. So the number in front of that x value would have been 0. So again, the slope of that line is 0.